All right, welcome to the AdaptX podcast, where we have conversations with individuals building accessible businesses, advocating for inclusion, or excelling in adaptive sports. Our intention is never to speak on behalf of those with disabilities, but to provide a platform to amplify their voice and share ideas for a more inclusive and accessible world. Today, I'm joined by Ray Browning. Ray is the CEO and co-founder of Biomotum, Inc., a wearable rehabilitation robotics company. Ray is an entrepreneur, innovator, and academic and clinical researcher with over 30 years of product development, startup, academic, and Fortune 100 experience. Ray has a strong technical and clinical background and has experience managing large research and product development programs and budgets. Ray has been involved in 3 startup companies in the clinical and health markets and has been successful in securing capital and non-dilutive grants to support these companies. Ray, thank you for joining me today.
It's great to be here, Brendan. Thanks for the invitation.
So it's been a few years since we kind of had our first conversation talking about wearables and cerebral palsy. For the listeners who might not be familiar with Biomotum, what's the story? How did it start? Who did you start it for?
Yeah, so I'll start with what it is that we're doing, and I'll work a little bit backwards. So we're building. I'm going to use. There's a bunch of ways to describe what we're doing. People will talk about them as exoskeletons, powered orthoses, or powered braces, or wearable robotics, and those can be used somewhat synonymously. So our strategy is take advantages in electrification of transport. So now you see electric bikes, electric skateboards, electric scooters, electric cars. That has made using electric power, and you can now add it to a brace, like we've done with prostheses for a while, and begin to improve gait rehabilitation and also assistive devices out in the community. So they can be adaptive, they can be powered. And so that's what we're working on. And that's been a really, as you said, our focus has been, for the most part, centered around pediatric and adult cerebral palsy in terms of individuals who want to improve their walking function. The origin story, Zach Lerner is the co-founder of the company with myself. Zach and I have been working together from his tenure as a graduate student in our lab about 12, 13 years ago. He came to do a PhD when I was a faculty member. And he and I both share this passion for the role that, I'll start with our legs, are really, in our opinion, our means of exploring the world. It's sort of one way that we get out and explore the world. And so we've always been interested in mobility, and Zach has a really strong interest in robotics. And so we've combined those two things to start to work on some technology that we think might be enabling for mobility. And I don't want to sound like, we'll get into it, I think, a little bit later about who's this for. It's an e-bike for your feet. It's for a lot of people. This isn't just a solution for one community or another. So we've been in existence for about 5 years. We've been working on the technology. We have a couple of kind of key product concepts in the pipeline. As you and the listeners are probably aware, bringing products like this to the market is time consuming. It takes a long time. There's a lot of regulatory hurdles to get over, and we're in the middle of that process right now. We'll probably have something in the market in the next year or two, for the community, and we can talk more specifically about who that is. We do know that when our device goes around the ankle joint, and we do know that when you can provide either assistance at the ankle joint during walking, or, if you provide assistance during walking at the ankle joint, a few obvious things happen. People can walk faster, they can walk with less effort, and they can generally walk with a posture that's more appropriate for reducing the risk of other musculoskeletal conditions, which is, I think, some of the objectives that you're trying to do. The thing that's interesting also, though, about the device is you can use it to functionally strengthen the muscles that are used in walking. So we have a mode where, it does feel very much like an e-bike, great. You walk, you feel the power, it comes into your ankle joint. It's like, wow, this is different experience. But you can also reverse that and make it more difficult for an individual to walk. So as they push, the device actually pushes against them. So, Brennan, you're an expert in adaptive fitness and strength training, and this is a way to develop functional strength while people are actually walking, which, as you know, is a somewhat difficult thing to accomplish. So that's a little bit about who we are, what we're doing. We're very small, 8 people, more, as you would expect, more biomedical engineering focused. Then that's kind of the core strength in the team, and then also med device development, because we're building a medical device. Wow. So what else can I tell you?
Yeah, that conversation of providing assistance versus resistance and whether it has a lasting effect was one thing that I wanted to ask about. I mean, I read Connor's paper. I'm actually connected with Ben a few times over separate topics as well. I think he's actually coming out to Boston to do his next residency. But the idea that once you take the piece off, are the effects lasting? Can you use the device as a training mechanism, I guess is what I'm trying to ask. When people use it in gait training or strength training, then they take it off. Are they finding that the functional improvements are lasting?
It's a really insightful question. And like a lot of answers for people that have neurological conditions, it depends.
Yeah.
I will say that what we know, and one of the cool things about working on technology like this is there are so many things we don't know, way more things that we don't know than we do. And what we're trying to do is get a tool out in the world to people like you, individuals who have disabilities, and individuals who treat those with disabilities, and learn as fast as possible from those teams how that tool is most effective. I will say, I think it's correct to say that we have good early data that the effects can be relatively long lasting. So we've done an intervention, as you mentioned, Connor's intervention, which was 4 weeks long, about 2 to 3 times a week of physical therapy using the device. And in that protocol, some of the participants, most of them were able to start with assistance at the ankle joint, but then progressed to resistance. So we took away the assistance and then added resistance later on in the intervention. And that transition period depended on how their starting function. Some of those kids came back a year later with no intervening intervention using our technology, and were able to had the same sort of mobility scores as at the end of the intervention. So there was some latency, some lasting effect. But I think what's important about that is I certainly give the effort of the participants and the therapists and the technology all some credit for making those improvements. But I think really what happens, and I'm sure you see it all the time, is when you give people another capability, they use it. And the more they use it, the more it reinforces that capability. And so these kids, when we ask them what do you attribute? This seems really, really positive. They were kind of well, duh. It's kind of a stupid question. How did you do it? And they're like, well, I used that new walking speed in everything that I did, right? I didn't think of myself as, I had another capability that I didn't have before. And so,
do you view it then in the same way that someone puts on their prosthetic? Do you view it as kind of a permanent solution to improve the movement options and the ability that someone has to use every day?
I think there's a number of different use cases. And I will say, I started by saying it depends a little bit. And I will say, in cerebral palsy, there's the GMFCS classification. So 1 being mildly impaired and 5 being severely impaired. And all of our work is in 1s, 2s, and 3s, individuals that are classified. One of the things that's really interesting is, 3s can be, as you know, that can be a challenging population in terms of ability to walk. It kind of goes across the board. Those individuals tend to make the largest gains with interventions. The 1s and 2s make improvements, but they're already relatively good walkers. And so, but the 3s probably need that device for longer and maybe over periods of time. So I can see 3 ways the device is used, at least our technology. One is, it's an intervention that's done to sort of top off a capability that a person has. Maybe you've got somebody with a mild disability, they're recovering from a stroke, right? There could be a number of cases. They're going to use the device maybe for 4 to 16 weeks, right? Really regain or get to a level of function, and they might not need it after that. One and done. There's this middle group that it's probably more episodic. It's top-offs. They come in, they do 4 weeks, they get much better. And that might be done at home, that might be done in your facility, that might be done at a physical therapy clinic. The third group is probably going to have a lifelong relationship with the technology. They might use it to rehab and get stronger, but they're also going to use it for daily assistive activities. And, so that's kind of how we see the utilization of a technology like this. And I'll just remind everybody that's based on what we know right now, which I'd say is like not very much. I think all kinds of other use cases are going to become known, and and that's another thing. I think it's really important to talk about, and I'm sure you've encountered this in your successful career, which is that it has traditionally taken a very long time for standard of care for individuals with disability to change. And what I hear a lot about in neurology in particular is, well, everybody is so unique and different that what I do with my patients might not apply with what you do with your patients. And I think there's probably some or a lot of truth to that. But what we haven't had is a way to kind of rapidly evaluate, hey, what's Brendan doing over there? He's, we have a device that has data that goes to the cloud. It's de-identified, you don't know who the person is, but I should be able to, once the device is in the market, I should be able to ping you and say, hey, Brendan, John over in Australia has been working with a patient population that's somewhat similar to yours. They have an actual patient that's similar to yours. Here's how they've been using the device, and here are the outcomes. And here's the settings. Here's how long. Here's the settings they're using. So the other thing we're really trying to do is create a community that's a data-driven community, which we hope then will accelerate the the adoption of this and other forms of technology and other things we learn along the way.
Yeah, I really like the premise of that, just being able to learn from other people that are doing it, not necessarily in the clinic or not necessarily in like a confined space, like research environment, but actually kind of out in the community with the same clients that we're trying to serve. You were mentioning the GMFCS levels, and with 3, you sometimes have athletes who are using loft-strand crutches. So I wonder if do you see, or have you seen maybe it takes someone who's ambulating with crutches and turn them into an independent walker? I have one client coming to mind who is kind of right on the cusp. Like sometimes he's able to walk across the gym without using his crutches, but he predominantly uses them. And I wonder if he would find this interesting to try out.
Yeah, we have a good video that I can share with you that demonstrates exactly that. So this is somebody I would say is a kind of maybe a GMFCS level 3, but on the mild side of 3. So able to walk, bilateral crutches. bilateral AFOs, and then we have a video of him. And we're starting to do a lot more work, excuse me, Brendan, in the community. So having people take devices home, use them in their daily activities, because we feel like that's, this is not just a clinical or research tool. And the video, this is not an intervention. So this is just, let's have you walk in the grocery store, and let's have you put on the device and walk in the grocery store, for example, or walk around your community. And it's pretty striking. It does exactly what you just described. He is able to, this is a young man who's probably 10 or 11 years old, is able to ambulate at a faster speed without the aids of the crutches, with the technology, with our device. And so I do think that there are individuals who will benefit in that way.
I think one of the pushbacks with like levels 4, 5, and even in like the spinal cord injury space, these exoskeletons where they're highly complex, they're expensive, they require several people to use. And when I have conversations with some individuals that meet that criteria, they use manual wheelchairs, they use electric wheelchairs, and you ask them if you could get this exoskeleton that takes 15, 20 minutes to set up so you can walk up a set of stairs or across the room, would you find that enriching? Like, would that make your life any better? And some of them say no, that they view their wheelchair as not necessarily something that has to be replaced. They view it as their freedom of movement. So I think it's interesting, this idea that you're improving functional capacity, you're giving people more options, but at the end of the day, it does have to be relatively non-invasive, and it has to be convenient. It has to be easy to use. So I think that's kind of one of the struggles, I guess, with some of this assistive technology is just getting it to a point where it's easy to implement.
It is, and it's we've kind of come at this from the other side. So I'm a huge supporter of the early efforts of Rewalk, Exo, other companies that have built large, as you describe, complex multi-joint systems that will allow an individual with near complete paralysis or lower extremity paralysis to walk. The miss is that's not a high priority. So when you ask individuals that have these conditions, some of them say, ambulation, I'd love to be able to walk. More of them say, I'd like to just be able to stand up, right? That and just look somebody in the eye and those kinds of conversations. And so I think, there's a little bit of, in this space, in the exoskeleton space in particular, we haven't been very good at listening to what the end user wants. We've sort of kind of bought into this idea that, well, everybody wants to walk like everybody else, and everybody, I think that's very disrespectful. What we see is, and hear, is there are people for which walking is more difficult than they would like it to be, but they still want to be able to walk. And we're not ever saying that if you can't walk our device, it would not be helpful. I mean, it's just not, that's not what it's for. It's for people who are ambulatory. They might have to use a walker, they might have to use, crutches or canes, but they can actually, support their own weight and walk. They might be using bilateral KFOs, AFOs, whatever it might be. But I think, we've learned a lot recently from the Australian healthcare system and how they deal with disability. And one of the things that's been most inspiring about that approach is, like you, it's all driven on what are the goals? What do you want to be able to do? And if it doesn't include walking, then our device is off the table. It's not in their list of things to do for the year. But if it does, then it offers us a potential solution that could be explored. And you're right, when you build complicated pieces of equipment for severely impaired individuals, everything gets messy. It takes a long time to put it on. It usually has to be done with the aid of a helper. the end results, I've always argued that, I don't know, if it was me, a 4.5 mile an hour wheelchair versus a 0.5 mile an hour exoskeleton, I mean, I don't know. I'd vote for the wheelchair. It's a really good tool. It gets people where they need to go. Cooking in your kitchen, maybe that's a different apparatus, right? I can. So I think we're trying. I'm not at all trying to be critical of the progress that's been made, and everybody, you have to start somewhere. But I do think, we have been, both Zach and I are married to physical therapists, so that's been super helpful. We kind of understand rehab, and we wanted to make something that an individual could put on in less than 3 minutes, and that we have been able to achieve that. It's so, but that also means the device is less complicated, less powerful, maybe less effective. I don't know, but if you can't get it on, it doesn't really matter how effective it is, right?
Yeah, so. I think ease of use I would rank as a higher priority to whether you can run with it versus walk with it, etc. I just think of one of my clients who's about 2 years post-stroke, who would really love faster gait, more controlled gait, benefiting from something like this. So have you guys tested it with stroke and SEI and other populations as well?
We have, although we have less data. So we've done incomplete spinal cord injury, stroke, Guillain-Barré, ALS, peripheral artery disease, CP. There are a number of conditions, and I would say that, I'll always use the term early, but the early results seem that the device can be helpful. It can be useful. Again, as long as it's aligned with the individual's goals. If the individual's goals are, oftentimes it's functional ambulation. So it's like, I want to be able to go up and down a set of stairs.
Yeah.
Tasks that are just not possible. And the other thing I'll say, Brennan, that's been really kind of powerful for me. It sounds simple from, probably from the perspective of, individuals that are living with disability, but when we talk with kids, in particular adolescents and young adults, what has become really clear to me is effective assistive technology, if possible, ideally is invisible. There's, we make a noisy machine, and that's one of the complaints about exoskeletons, right? Is that there's here comes the robot person, right? And so what I'm hearing loud and clear from individuals is, can you please not draw attention to me? I don't need that in my life. I don't want to walk into a supermarket and have everybody stare at me because I've got this kind of cool looking thing on that they're hearing, not that they're, may not even see it. And that's been a really, for us, helpful insight, because it's driving the design decisions that we're making. Like, okay, how do you make something like this quiet? How do you sound insulate? Where's that noise coming from? Can we minimize the form factor so it's easy to go under a loose pair of pants, or and so those are really key focus areas for us now. Is how do you package this in a way that maximizes its adoption so that people will actually take and use it, whether it's for therapy or whether it's for activities of daily living or occupation, work, whatever it happens to be. And you have to be willing to listen to a lot of people and have them tell you that, like, I've had a lot of people tell us, I'd never use your device. I'm like, why? A lot of it is that it's too bulky, it's too this, it's too noisy. My bilateral AFOs and crutches are quiet.
Yeah. Yeah,
It'll
I
make,
think it's really important that you kind of have already come to that realization, because it was actually a similar conversation that I just had with someone last week. Is sometimes we love being the ones to come up with solutions, albeit sometimes complex, that we don't quite understand that sometimes the adoption of assistive tech can be ostracizing to especially like adolescents and youth, when it amplifies their differences more so than mitigates them. So sometimes we have adaptive equipment in the gym, and some of our athletes don't like using it. They would prefer that we just come up with more discrete solutions to kind of keep them training alongside their peers without
yep.
drawing more attention to their limb differences or their challenges. So yeah, like you said, you just gotta, I guess, understand what the user wants. And one of the best characteristics of both an adaptive fitness professional and I guess a researcher and a developer in the adaptive equipment space is just the humility to, I guess, recognize that we don't have all the answers, but our consumers do.
Yeah, and I mean, gosh, these are individuals that have lived experience with it. I mean, and you do have to have the humility to admit that we don't have that right. We don't have that right yet. That's not, and I can see why, companies sometimes decide, oh well,
Yeah.
but that's not how I would like us to be perceived.
Can you explain how the tech works? I guess, like, so maybe from start to finish, someone puts it on, et cetera, what's working within the device?
Yeah, so I'll explain that we have a form factor or a design right now that we're using, and it's being used in a lot of research facilities around the world because that's a fairly common starting place. And then I'll explain a little bit about where we're heading because that'll kind of give a roadmap. The functional description will be essentially the same in terms of how the device works. But so we have a carbon fiber foot plate that goes inside the footwear. Usually works quite well because it's thin. It's about maybe 1.5 millimeters or 2 millimeters. So if somebody's been using an AFO, they have enough room in their footwear to slide that in. It goes into the shoe, and it has a sensor under the forefoot, under the balls of your feet, which is a pressure sensor. And that foot plate is connected to an ankle joint, which can pivot and rotate. And that ankle joint then is connected by cables. It's got like a pulley on the end of it that goes up the leg to a little waist pack that carries motors and batteries and the computer controller. And so what happens is that this is a little bit, think of it a little bit like though the pressure sensor under the foot is a little bit like a gas pedal. So the harder you push when you walk, especially in late stance, so you're pushing down into the ground, the more torque the motors will produce to aid that assistance. And so if you look at how the device works, it's responding to that pressure as opposed to prescribing a particular way to use your ankle. And we found that prescription is really difficult because everybody walks. We're not in the business of saying how you should walk. We're in the business of augmenting how you walk. And then you, as the professional or a physical therapist or others, they're the coaches that guide the proper walking that they would like to see. So as you walk, you push down. That sends a signal to our computer, which says, okay, motors, produce about this amount of torque. And it's always a proportion of that pressure. So we're never replacing the ankle musculature. We're just adding something to it. In cases where you have severely atrophied ankle plantar flexor muscles, calf muscles, the device may be producing a lot of the torque for the ankle joint. In other cases, it's producing less. But so as you walk, you push down, that sends a signal, the motors send the torque down to the ankle joint, and that actuates the device. And that happens essentially in real time. So it's adjusting. Why that's, I think, helpful is, let's say you approach a set of stairs or go down a ramp or are on uneven surfaces. Our device is just responding to how you are moving, and how you move when you approach a set of stairs is different than it is when you walk over ground. you tend to push down more on a set of stairs, right, to plantar flex your foot to get to the next step. And so that's the basic function, so it's a feedback loop, a closed loop feedback system that's measuring, estimating how much torque to send. That torque gets sent via the motors and these cables that go around the ankle, and then that moves the ankle joint. What we do in resistance mode is we take that pressure and that estimated torque and we reverse the torque. So instead of it being moving in the same direction as your foot is moving, it's actually moving in the opposite direction. So the harder you push, and in that case, the device acts a little bit not like a gas pedal, but like a brake. So, as you're pushing down, you're feeling resistance against you, and you're overcoming that resistance as you walk. So the difference in form factors, so that device, has we've used a waist-mounted sort of computer battery motor pack because we want to keep the weight at the leg as light as possible. As you're well aware, adding a couple of pounds below the knee is problematic for people who can't walk well. I mean, it's very hard to control that much weight down their lower leg, even if you're healthy, let alone, if you have neurologic impairments. However, we are increasingly confident that there is a lower leg form factor, that the whole thing will sit, from the knee basically down to the ground. And that's what we're working on right now is a new generation of the device, which the motors, the controllers, and the sensing is all local to the leg. You might have a small battery that sits like in a belt, that you wear, like something really, really small. That is the form factor, Brennan, that we think is the most attuned to the user's expectations. Slide it on, put clothing over it or not. You make the design aesthetically appropriate. That could be customized for the individual. And then the other thing that we're working on is noise reduction. So how do you make it quiet, or as quiet as an ambient background noise might be? Does that help? Does that explain it?
Yeah, absolutely. I'm thinking as you were explaining it, I guess what the use case is of providing resistance. So the population that's using this is predominantly those that need assistance. And I wonder at what threshold or at what point you determine, okay, this client now needs resistance.
Yeah. So generally what we find is GMFCS level 1 and 2 kids, not kids, individuals, although we have a lot of data on, kids and adolescents, they really benefit from resistance. They actually need stronger functional muscles at the calf. That really kind of tops off their capability, gets them up to a 6-minute walk test distance that's comparable to healthy peers. And so it feels like, and what they describe is the device in resistance mode is actually providing some proprioceptive feedback. It's giving them a signal to plantar flex, right? Because as they start to move forward, their center of mass goes over, their feet, and now they're pressing down in the balls of their feet. They're feeling this pushback. Oh, okay, that's the signal for me now to really actively engage my plantar flexors. And that's super important, because if these kids, or these individuals, even if they've been using a rigid AFO for any period of time, they have lost that ability to even engage their ankle. You can take a person in our device. One of the things that I will do is, hey, let's get it on, have you walk. Now I want you to just go up on your toes. And they're like, what? Yeah, just go ahead and just, go up on your toes. Like you're going to, just go up on the balls of your feet. Something that they haven't been able to do for, in many cases, years, because they're locked in at the ankle joint. So resistance works well for people that have a higher functional capacity and are really wanting to top off their function, like to do things that are more difficult and intense, like stairs, ramps, and other things. And their goal is to do it without using the assistive device. They're going to use it as a strength training mechanism. So
Yeah. That's what I was basically kind of figuring out or arriving at there, that the device then just becomes a training modality more so than an assistive device.
Exactly. Yep.
Yeah.
And the idea is that if you have one of these at home, you can do both, right? I mean, you could go out and spend 15 or 20 minutes walking in resistance mode. We do have a biofeedback and gamification built into this new version of the device that we're working on, where you can set a target walking function score that you want to achieve, and it'll give you auditory, haptic, or visual feedback on how well you're doing that. So, and that's pretty easy to do when you have resistance. I mean, you're just trying to exceed a resistance target. So that's kind of fun.
Are they universally fitting, as in could I have a pair at my gym that 7 or 8 different clients use, or do they have to be individualized?
So I think the answer to that question is we have found that most individuals, with the exception of those with very significant foot deformity, can do it. They can put it inside. Sometimes they have an orthoses or an insole, a custom insole that can go right on top of the carbon fiber foot plate, or even an SMO. For individuals with more impair or foot deformity, I think the strategy would be that we might have to, or they might have to have an orthoses made that's in the shape of the foot, that would then be made by an orthotist that sits on top of the foot plate. So it just provides that level of support if they have a really equinus gait, or they have significant pronation or supination of the foot, and the foot plate is conducive to that addition. But we've done clinical trials where we have the devices with the only thing that you would change as a practitioner is the size of the foot plate for the individual. So if somebody's a size 7, and we run from size 4 to size 13. So you'd have a suite of tools, and it takes, I don't know, 2 minutes, a minute and a half to change the foot plates. So you have a new patient coming in, new person, chuk-chung, off you go. But that's also, we're really excited to begin, working with moving outside of research into clinicians to answer that question. Like, okay, do we need to make some add-on components to the foot plates? Oh, if you have patients that are like this, use this wedge, or use this, and it might be something that's not custom, but does a better job of supporting the foot.
We are grateful for the support of our first show sponsor. Resolution Fitness offers leading brand health club equipment and accessories for residential and commercial use. In addition to traditional exercise equipment, they specialize in adaptive fitness products and wheelchair accessible machines. If you're interested in outfitting your fitness facility or home gym to be more accessible, visit www.resolutionfitness.ca or the link in the show notes below. I won't be able to hash this topic up too much since it's beyond my area of expertise, but just aware of it as an industry trend. Has the evolution of AI over the last couple of years been implemented into your projects or products, and has it changed anything, I guess?
Yeah. So the short answer is yes. And one of the ways that we have adopted AI is we're building kind of a dynamic biofeedback engine that's data driven, and uses some basic techniques of AI to try to appropriately establish a biofeedback threshold level depending on how the person's walking, and that's really a kind of an aid to the individual or the therapist. We do have in our roadmap that capability that I described of kind of sharing settings can be obviously much more advanced than that, right? I mean, it can be so yes, we have we basically have an onboard computer that's connected via Bluetooth to the cloud, and that data then will be used, and we'll use some AI techniques. I will say, however, that our philosophy is always to be a tool, not a person, or not a, I think I'm most excited about what we learn works from professionals and users of the technology, not what AI tells us might work. I think we have a decade of time in devices like this that we're going to need in order to be able to start to provide, coaching. And that really stems from we need a lot of people like you in the world that are hands-on with individuals, coach them, encourage them, work with them. And our device needs to support what you do and what these individuals want to do. It isn't up to us to have an AI anything that sort of short circuits that anyway. So if you tell me, Ray, hey, I would love some intelligent assistance. I'd love a little chatbot that kind of helped me prescribe or what to do next. Okay, sure, we would make that. But that's not the intent going in. We're not trying to automate therapy.
Yeah. I guess you kind of mentioned earlier that it's a 4 or 5 beyond process of bringing a product like this to market. And I just know, like I mentioned, it's not my wheelhouse, but I know how much AI and technology has changed over the last 2 years, that it's like, if that process of development takes so long and then the technology is kind of ever evolving, it's probably tough to continuously implement and iterate, etc. But yeah, like you said, I think it's better if there's a human-centric component to it as well. Like we talked about before, the end user is the one that kind of determines what their experience should be like, not some large language model telling you what your experience should be like. But maybe let's talk about the economics of it and kind of the bringing it to market. So the biggest gripe, I guess, with a lot of assistive technology is the price point and the accessibility of it in that regard. So maybe with yours being intended for the user and the community, et cetera, I guess, how do you get it to a point where people with disabilities can afford it and access it more freely?
Yeah, so I want to talk about 2 things. It's a really relevant topic, and when Zach and I started this, one of the primary motivations was not to build another $50,000 exoskeleton that works great, but people can't get access to because they're having to pay out of pocket for it. That just felt not very helpful. It felt hopeful, but not helpful. And that didn't seem like a very good strategy. So in the medical side of things, well, I'll start by saying that there have been so many advances in robotics and electrification of transport that now you have well-defined ways to control robots, that you're not spending huge amounts of time building custom computer programs. A lot of those are, bits and pieces have been written. The second thing's motors, batteries, and electromechanical systems are infinitely cheaper than they were even 5 years ago. And so the platforms by which these technologies are built are becoming much less expensive. What happens in the healthcare system is that, at least, and we're experiencing this firsthand, one is it's super expensive to develop in this environment. The regulated, highly regulated environments they're just time consuming, and it takes a lot more people. And so manufacturers are trying to recoup some of those R&D costs. And one of the ways they do it is by raising the price of the product. And that makes good economic sense. You can't stay in business without it. But I think there's a volume play, right? Where if you can make a product in the medical space not that expensive, then it's more accessible to individuals prior to reimbursement. And there's all of these devices are going to be reimbursed at some point in the future. That's happening already. You're starting to see Exo has reimbursement, Rewalk has reimbursement, Kyogo has reimbursement. The Autobox C-Brace, which is a CAFO that's microprocessor controlled, it doesn't produce power in the joint. Those are reimbursed. So there's a clear trend toward these more advanced systems becoming reimbursable. But I think what's even more interesting from the medical side is, and this is kind of my own crystal ball, that, okay, I'll use a specific example. Skip Robotics, which is a Google X spinoff, just partnered with Arc'teryx to make a pair of trousers, basically, or pants, hiking pants that have an exoskeleton, the exoskeleton built into them. $4,500. So you got a $40,000 Autobox C-Brace, you got a $4,000 pair of electric pants. You can see sort of what's going to start to happen is consumers, patients, are going to, well, wait, why is that much when I can get essentially the same thing for that much? And I think we're about to enter a period of time where the cost of a lot of this technology is going to go down considerably. The other thing, so that's kind of on the healthcare side, for us to get a device cleared into market, how much will all device cost initially? Yeah, it's probably going to be $10,000 to recoup some of those costs. Target price for us is the same as a pair of custom AFOs. That's the goal. So right now, parents and individuals are paying $2,500 to $3,500, maybe $5,000 for a pair of custom-built ankle foot orthoses bilateral. We think we can do the same thing, but power it. That would be the goal, because that starts to become very achievable, and there's no reason that insurance wouldn't cover it, because it's a more effective solution at the same cost that they're paying right now. Let me switch to the consumer side. Because as an e-bike for your feet, you don't have to sell it as a medical device, right? You can make a medical device and you can do all of that. But at the same time, you can go over here and say, hey, if you just like to be outside and want to walk around instead of ride a bike, right? For example, here's an e-bike for your feet. And we're very, very interested in that approach. One of the main reasons is for the catalyst for this. We went to the Consumer Electronics Show 2 years ago, and we had a booth there, and it was part of an assistive tech devices for individuals with disability. Super exciting. 95% of the people that came to the booth wanted to use it for an older parent, somebody who just was slowing down. They didn't have a diagnosed medical condition, right? They weren't interested in, well, they have such and such and such and such. They're just like, hey, my dad's getting old, likes to play golf, is having a hard time getting 9 holes in without getting super tired. Would this work? And we're like, I don't know, we've never tried to play golf in it, but it seems like it might. So there's this other kind of world out there for what I'll call augmentive solutions, which I think is going to bleed back into that families will have, individuals with disability are going to have tools that they never thought they would have. And they're going to be at prices that are, I think you could make a set of electric hiking boots for $300 or $400.
Yeah.
And essentially what you're delivering is a really, really cool solution for a fraction of the cost of what it would be as a medical device.
Yeah, the implications of that are obviously exciting. And then, I guess you're addressing the price point piece, and then you're addressing the noises and the compatibility of it, and just the seamless integration of it within daily life. Is there a way for you to get some of those traditional robotic noises and such removed, I guess?
Yeah, there is. It's interesting in that. So there's 2 ways to do it. One is in terms of how the device is controlled, And so we use, remember, what I call a closed loop controller. So the motors are always just kind of fine tuning their expected torque output. And so the actual mechanical motor itself and driver are trying to change the current to the motor, like back and forth, back and forth, back and forth, 500 times a second. That's noisy. We've tried open loop control, which is you just send a current command to the motor. You're not back and forth. It's not closing a loop. It's just you're going to drive a current that's proportional to what you see. It's a little bit right now. We're not convinced it's the same level of risk. It might have some higher risk. It may not work quite as well in certain conditions, but it's amazingly more quiet. So that's one. There's an electromechanical kind of approach, and the other is, of course, you know where the noise is coming from, and you just sound insulate. Which, when you look at most devices, they don't. They take a motor, it's either a disc or a long cylinder, and they throw it inside a plastic enclosure, and it is what it is. There is no attempt to sound insulate, which is kind of odd to me that we're 20 years into building exoskeletons and we're just now thinking about making them quiet. I don't know, it just kind of feels like that took a little longer than it should have to put that on high on the priority list, but oh well.
What's on your priority list for kind of the roadmap the next 5 or 10 years? Do you I guess what do you envision accomplishing? Do you envision other products? Are you guys central to the Spark product?
We will always be involved in lower extremity powered solutions. So I'd say that the roadmap. There are lots and lots of super talented people doing spine and upper extremity, and we don't. That's not our wheelhouse. So we're going to stick with the lower legs or the limbs, the legs. We've been playing around with some solutions at the hip. They're early. We've got obviously a whole bunch of work at the ankle joint that translates to some effectiveness at the knee, which is interesting. There's hybrid combinations. There's different controllers. There's a lot of work to do. There's direct to consumer has its own sort of set of product considerations and how you do that, and how you do that at super high volumes, like in the if you're in the millions of these, how long you want it to last. One of the big questions, Brendan, is these devices generally require some education, some training. So if you are selling it to a consumer, how do you do that? Like what is it that person gets it out of the box and goes, well, now what? Right? And this is where sometimes an AI sort of start engine may be really important, right? It's sort of, okay, we're going to have you walk for a little while. We're going to play around with some settings, and we're going to optimize that based on what we know works for other people. So our roadmap is our expertise is in hardware and software around improving mobility with powered bracing. We're not replacing limbs. We're not interested in prostheses. It's always going to be for individuals with intact limbs.
Awesome. Here, let me grab one thing. I got to plug in my headphones.
Yeah, no worries.
Just getting faint. Can you still hear me okay?
They can, yep.
Perfect. So one of the questions that we typically ask our guests is whether they have any advice, more fitness industry specific, I guess, as to how physical activity or fitness can become more accessible for people with disabilities. Your product obviously plays into that. It's going to improve the efficacy of people's movement and their ability to access movement. But what do you think maybe would pay the largest dividends in making fitness more accessible for people with mobility impairments and disabilities?
My answer to that question is We just have to have the conversation with them. So it has to be driven by what individuals want to achieve, and I'll say that that's not a cop out. That's just a recognition that not being a person with lived experience, I don't know what it is that is exciting or interesting or important for an individual. And I'm sure it changes, it varies by individual. I will say though that one thing I really hope happens, Brendan, is, as these kinds of technological solutions, these aids become more, they're going to become more sophisticated, they're going to get smarter, they're going to do things. I hope that we celebrate the uniqueness of individuals with disability and their ability to move in their own way. And that's really what I hope. Is we oftentimes try to box people in, like, oh, you need to walk like I walk, or you need to, move like I move. And I think we're entering an era where our tools and our goals for individuals should be to move in the way that's best for you to move. And it doesn't have to look like what we think, is optimal. Because a lot of the technology, right, is pushing people towards this vision of, in our case, what normal walking looks like. And I hope we move away from that and not, not box people into, oh, it's got to look like this. Riding a bike has to look like this. Walking has to look like this. Running has to look like this. Weightlifting has to look like this. And we use able-bodied models as the sort of, the criteria. And that's really, I think, that acceptance is one of the things that I would advocate, is how can we make tools that allow people to engage in activities that bring them joy. I don't care what you call it. But if I see somebody and they clearly are enjoying what they're doing, check, success. I can leave this planet feeling like I've made it a little bit better than it was. So it's not about necessarily, there are many people like you and many, many others who are advocating for, places, opportunities to access, the outdoors. I'm going to let that whole conversation go to those individuals. I just want us to be able to celebrate the fact that people can move. And I don't want to judge it. I don't think any of us should judge it. I think we should really work hard to say, that's beautiful. That's amazing that person can do that, right? And just have that be enough. So that's kind of my perspective.
Yeah, that's a very well-aligned response to some of the stuff that we teach to fitness professionals when we talk about like the social model versus the medical model of disability, and how the medical model kind of standardized the definition of normal that everyone was supposed to adhere to. And even in exercise, you're taught about specific techniques. And then once you notice that everyone moves slightly differently, you can be easily thrown off by that, I suppose, if you expect everyone to move one way, and then in reality you realize that that's never going to be the case. So I actually really love to hear a medical, and I know you're not a strictly medical device company, but someone building a medical device product, recognizing that it's not, we have to strive for one specific use case or one specific trajectory or gait, but it's working with what they have to accomplish what they want. And I find that to be a very, very great answer.
Everybody's asymmetrical, goofy, they have something, right? So if we can amplify and augment people's experience exploring the world, full stop, I'm done. That's great. I'm not going to judge what it looks like. I'm not going to judge what it feels like. But if I see somebody out there and they are clearly enjoying it, You know,
That's a
and they have
successful
our
product.
device, and they've got the torque set to 0 on one side and 10 on the other. I don't care.
Yeah. Yeah.
You know, I'm not going to worry about the. You know, I'm just like, you're out here. Good for you. Yeah. So, yep.
How could our audience support your work, whether it's a facility implementing your devices or a user looking for your product? I guess give you like a chance to kind of plug and.
So I would say that sign up, go to our website, sign up for our newsletter. We love to communicate with people. We like hearing from people. I like hearing, you know, I tend to, believe it or not, respond to most contact us inquiries. I try to respond to a lot of them. I learn a great deal. We are in the process of what I would call continuous customer discovery. So I like hearing from people. I like hearing, that's a great way to support us because it meets us where we are right now, which is wanting to hear from individuals. You know, we don't have a product on the market yet. That's going to take a little longer. So I want people to understand that we're working as fast as we can, and the more information we can get about what you need, the better. So,
Awesome.
you know, tell us your story. That's you know, what is it? And tell us the story of what you want to do. What's a goal you have? I would love to hear from people that say, I want to fill in the blank. So that would be great. Brendan, I would really appreciate that people go and just, it's easy. They can go and, you know, fill out a form there, or they can just subscribe to our newsletter. That would be super helpful.
Yeah, we'll include the link to do so in the show notes so people can easily find that. And then social media, websites, we can include some links for those as well for people to stay in touch and stay up to date with product developments. But Ray, it was really interesting to hear where you're at and where you're going. I really like the direction that you're going, obviously, as someone who cares a lot about getting adaptive equipment, assistive technology into consumers' hands and not just in the clinical setting. I feel like sometimes it exists so much in the research environment that it doesn't really realistically get to the user in a way that can kind of change their day-to-day life. And so I love that that's at the forefront of your thinking, and really appreciate you spending an hour this morning sharing more about the company.
Yeah, well, it's same, Brendan. I have a tremendous amount of respect for what you're doing. You know, you're making a big difference, both in terms of the people you work directly with, but the people that you train to work with others. So I love it when people have a multiplier effect. So yeah, I'm honored to be here. Onward, here we go.
Yeah, we'll look forward to staying in touch and seeing how we can work together in the future.
Same.
Thank you for listening to the AdaptX podcast. Our effort to amplify the ideas of our guests and create more inclusive and accessible industries is futile unless these episodes reach a larger audience. If you enjoyed our discussion today, please leave us a rating or a review on whichever platform you use. And if you would like to learn more about AdaptX, the course that we teach to health and fitness professionals and the projects that our organization is working on, you can subscribe to our newsletter through our website, www.adaptx.org. Until next Monday.